Hi guys, our topic for today is about anti-derivatives. Okay, what is anti-derivatives? Anti-derivatives is actually integration. Okay, so what is integration? Okay, let's go back with taking the derivatives of functions first. Okay, let's say you have an equation y is equal to x squared plus 2x plus 1. Okay, in differential calculus, what we're going to do is to take the derivative of this function with respect to x. In doing so, we will have dy over dx equal to 2x plus 2. Derivative of x is, of 1, I'm sorry, the derivative of 1 is 0. Okay, if we're going to rearrange this will look like dy is equal to quantity 2x plus 2 times dx. Okay, this one is what you call derivative. Okay, this one is differential. Okay. Now, in integral calculus, we have that principle, integral of x raised to n times dx equal to x raised to n plus 1 all over n plus 1. In derivatives, we subtract power. In integral, we add 1 plus a certain constant c. Now, what is c? C is what you call as your arbitrary constant of integration. Okay, later I will arbitrary constant of integration. Okay, later I will tell you more about this arbitrary constant. Okay, also, in integral calculus, the integral of dy is equal to y since the differential of y is dy. Like in this case, differential of y is dy, differential of x is dx. In the same way, or in the same manner, that the integral of dx is equal to x. Now, making use of this three principle, let us try to recover the original equation by using integration. Okay, you have dy is equal to quantity 2x plus 2 times dx. Now, guys, in derivative, we also take the derivative of this function term by term. Meaning, you can take the derivative of x or of y and x squared, 2x, and 1 individually. In the same way, in integration, we can also perform integration term by term. In derivative, you take out the constant and just take the derivative of the variable. In integration, the same thing applies. You take out the constant and just deal with the integral of your function or your variables. So in this case, by distributing everything, you will have dy is equal to 2, taking out 2 as constant, then you will have x dx plus 2 integral of dx. Okay. So, integrating both sides, you will have now y is equal to 2. Now, what is the integral of x dx? Now, going here, applying this we call this actually power formula. If we are going to apply this, what does the integral of x raised to n dx means? It means that your x is the integrand and your n is the power. And dx stands for the derivative of x. In this case, x is your integrand. The derivative of x is 1. So you don't have to put times 1. Then the differential is dx. Okay. So, therefore, we can make use of this formula so we will be able to integrate this. So, in that case, you will have now x, your power is 1, you add 1, and then all over that power, which is n plus 1. In this case, this is 1 plus 1, so the denominator is 1 plus 1. Plus 2, then integral of dx. What's the integral of dx? As what we have said earlier, the integral of dx is x plus the arbitrary constant of integration. Now, simplifying, you will have y is equal to 2 quantity x squared all over 2 plus 2x plus c, canceling 2 and 1 half, you will have y is equal to x squared plus 2x plus c. Now, if you are going to compare this from the original equation, the original equation says it's 1. Your answer says it's c. Why is that so? Because if you take the derivative of a constant, that is 0. So in that case, when you integrate a certain function, when your limit is indefinite, meaning you don't have a lower and upper limit, you will have this what you call arbitrary constant of integration. Meaning, this is what you call as family of curves. What kind of curve? What kind of curve? You have your x as square and the other is linear. So meaning this is what? Parabola. So it means that your solution shows families of parabola. So that's the way how to do integration. So antiderivative is about recovering the original functions after you took the derivative. So integration, what we do is just recover the original equation before the original function was taken the derivative. So in that case, you have the derivative as dy dx equal to 2x plus 2. If you take the integral of this, you will have this answer. Y is equal to x squared plus 2x plus c. Okay. See you soon for more samples.